The wireless Geiger counter is an engaging device that allows your students to explore the invisible world of radioactivity. The PASCO wireless Geiger counter comes with a charging cable and a threaded rod that makes it easy to clamp to a ring stand. After powering it on, it'll start measuring radiation, beeping at every count. In this case, the counts are from background radiation. The beeps can be muted with a short press of the power button. 2 quick beeps confirm that I muted it. The wireless Geiger counter can connect to either SparkView or PASCO Capstone software. Let's use SparkView and create a graph of counts versus time. The default is counts measured in a 30-second period. The time interval can be changed to anything from 1 hour to 1/10 of a second. I'm going to set it to 2 seconds and click Start. You can see the background count appear after each 2-second interval. Increasing the interval would increase the number of counts represented by each point on the graph. After I place this red radiation sample disk under the Geiger counter, the graph shows a count greater than the background. For a more accurate measurement of the sample's count, the background should be subtracted. What will happen if I place this piece of paper over the sample disk? The counts drop back to background. The radiation from the sample can be stopped by a piece of paper. Let's try the green disk. It causes counts above the background too. Can paper stop the radiation? Not as much. Let's try 16 sheets of heavy-duty aluminum foil. It stops about half the radiation. Will 32 sheets stop all of it? Your students will want to find out for themselves. Now let's try the orange disk. The count shows it's radioactive too. Paper has no effect. The radiation passes right through paper. And 32 and 64 sheets of foil. Your students can use these observations to identify what type of radiation is emitted from each disk and to identify unknown sources of radiation. How can we stop the gamma radiation coming from the orange disk? You could try other materials like lead or water, or increase the distance. Careful measurements of the counts versus distance will reveal an inverse square relationship. Remote data logging is an exciting new feature of the wireless Geiger counter. It allows background radiation to be measured at remote locations and while traveling. Just set it up, put it in your backpack, and forget it. Remote logging does the rest. Let's set it up to measure the background radiation. So I click Start New Experiment. And now select Remote Logging. I'll increase sample interval to 10 minutes to get a higher background count. The software gives an estimate of how long it can collect data based on the sensor's memory, but battery power also needs to be considered. I can defer the start of logging to when I press the power button or click OK and start logging now. I configured this Geiger counter for remote logging a few days ago. I wanted to answer the question, what happens to the background count when the sun goes down? The data can be downloaded by clicking remote logging again. It detects that there is logged data and asks what I want to do. Let's download the data and display it as a graph. Changing the x-axis to date and time makes it easy to tell that the background did not change when the sun went down. Starts at about 3 p.m. here and stayed pretty steady. What will happen to the background in an underground parking lot or a cave, a hospital, driving to the mountains, flying in a plane, going through airport security screening? The possibilities are limited only by your ability to ask questions. There's more information, videos, experiments, and useful accessories for the wireless Geiger counter on the product page at PASCO.com. Thanks for watching.